So thank you all for joining us tonight. And let me kick it off to Bob Shapiro, one of our co-chairs of Fuel the Flash 2030. Bob?
Thanks, Laura. And thanks everybody for joining us tonight. And also, if you're joining us tonight, you're one of our very generous donors, and we certainly want to acknowledge that and thank you for that. I've been absolutely amazed at generosity of the people in the Lightning class, and thank you. So Bertie and I, as Laura said, are co-chairing the Fuel the Flash 2030 fundraising campaign. We've both been in lightning sailing for about a million years, me more millions than her. And Bertie's located in the Midwest, and I'm from New England. And we'll be making sure we stay on track today. And I want to start by introducing our panelists for the night. I think a couple of whom are not quite on the Zoom yet, but at least you'll see their pictures on the slide that Bertie's showing. I really hope the first two people don't need an introduction, but I'm going to do it anyway. Dave Stark is president of the Lightning class. He's a multi-time Lightning World Champion, Southern Circuit Champion, Canadian Champion, and North American Champion. But he's a slacker because he only won the Junior North American Championships on one occasion. He's won the U.S. Sailing Championship of Champions, been nominated for the Rolex Yachtsman of the Year award, and I hope you all know that he works his butt off for the Lightning class, and we certainly all appreciate it. Another person doesn't really need an introduction is Tom Allen, who leads Allen Boat Company. Patrick O'Connor is next on the panel. He's the lead at Green Flash Solutions, which specializes in 3D scanning, metrology, reverse engineering, and prototyping using parametric modeling and 3D printing. They're able to make sure the parts designed are perfect before sending them on to manufacturing, which is certainly important for us. Their primary clients are high-end sailboat racing teams around the world, but they also work within the commercial industry. He's been a professional sailor, a boat captain, a project manager, and LinkedIn tells me that he worked at Allen Boat Company from 2005 to 2011. I hope your LinkedIn was accurate, Patrick.
It's accurate, yeah. Yeah, it was very cool. PJ got in touch with Andrew, next on the panelist, to scan the molds and to start the conversation. And Andrew was just like, "Oh, we're going to Buffalo. You got to come." And then I told Andrew that I worked for Tom when I was in college, I guess, on breaks and stuff. So it's it was a cool, really cool call to get and a cool experience. And I hadn't seen Tom in 15 years, and so it was really cool to have the opportunity to get involved in this and to be back kind of talking about lightnings again. So very, very cool to be involved, and thank you for inviting me, and looking forward to seeing what we come up with.
Super. We're happy to have you involved, Patrick. And Andrew Williams is the principal at Marine Measurement Systems. He's been measuring marine hulls since 1992 using HMIs. Bertie's going to give out $1 to anybody who knows what HMIs are. I don't. Laser trackers, total stations, and laser scanning. He's been the chief measurer in many world championships, was a member of the Athens Olympic measurement team in 2004, and his specialties include modeling into surfaces. So welcome and thank you for joining, Andrew. PJ Schaefer is heading up the new molds committee. PJ is an engineer at Safe Harbor New England Boatworks.
Perfect, thank you.
Sorry? At Safe Harbor New England Boatworks in Portsmouth, Rhode Island. He's a longtime Lightning sailor, and he's been a mentor for a Rhode Island-based boat grant team as well a couple of years ago. There are an awful lot of parts to figuring out the process and the people and the companies and all the handoffs between. And PJ is working hard to make all of that happen. So thank you, PJ. And the last person on the panel, Dave Sprague. He's been instrumental in keeping us as an international class, keeping us in the Pan Am Games, representing us at World Sailing, and I'm sure a million other things. In the 1980s, Dave was chief measurer and at another point also president of the class, and he's recently stepped in to temporarily fill the chief measurer position again, just in time to help out with the New Molds project. So welcome all the panelists and thank you for joining. To talk just for a moment about the fundraising campaign, the overview is that we're trying to raise money so that we can do things to positively impact class growth and sailing participation in lightnings. That's what we're trying to achieve, and the things around the outside of the picture on the screen are the things that we're doing in order to accomplish those. So today we're focused on new boat production. We know that it's critical for our future success to have the ability to build new boats well into the future, well past our 100-year anniversary. So why are we focused on new molds? Well, the molds that Alan is using right now are near their end of life, require a lot of extra effort and time in order to make up for the inadequacies and the aging of the molds. And it's critical to ensure we have ongoing production capability. You know, if we don't have the ability to build new boats, we're not going to attract the kind of people to the class that we want to. So it's critical to make sure that we continue to have that capability. So we have a multidisciplinary team, many of whom are on the panel, but some of whom are perhaps not even selected yet and not involved yet, who will help to achieve this goal. And the picture on the bottom there is of the original Skaneateles mold that was used to, the first boat out of that mold was Lightning number 5, which we hope to acquire in the next couple of years. It's currently being rehabbed.
Good.
So in December, a collection of people were at Allen Boat Company to start the process of creating the new molds. And here's about a 5-minute video that Bill Foudy took that explains that process and shows you what was going on.
Hi, this is Tom Allen. We're at the Allen Boat Company, and today we are scanning the molds for preparation to eventually, hopefully, making some new molds. So there's a age and a lifespan for every mold that you build, no matter how you build it. When my father and I built these molds, we built them for longevity, and they've been around for a long time. But even in that capacity, they've been used for a long time. And so the molds can shift, the molds can get damaged. The molds are pretty far along in their lifetime. So we really need to start thinking about upgrading.
I'm Pat O'Connor from Newport, Rhode Island, and we are at the Allen Boat Company in Buffalo, New York, here to 3D scan the molds for the Lightning class. The ultimate goal is we are going to see if there's any deformation, any issues with the molds, whether they're symmetric, and the end goal is to produce new tooling for the hull, the deck, the inserts, and all the parts that go into building a Lightning.
I'm Andrew Williams from Marine Measurements. Once we have the data, we're going to turn the data into what we call surfaces. And then from these surfaces, an electronic machine called a CNC can actually cut out a new version of this. The new version will be saved digitally. So at any stage they want to build another mold or more molds, it can be all done to the same degree. We're using what's called a Creaform 3D Max, which is a hand scanner. For this particular scanner to work, we have to place dots on it. And then we measure the dots so that the software knows where the dots are. And then from there, we kind of turn this laser part on, and that then captures the actual shape of the boat. The Creaform is a very accurate machine. We can get down to 40 microns with that pretty easily. There's 1,000 microns to a millimeter. And a human hair is about 110, 120 microns. So we're cutting a human hair in half.
We're using a tripod-mounted scanner called a Faro Focus S. and the Pharaoh is mounted on a tripod and then shoots a laser out to a mirror, and then the mirror spins and captures all the data vertically. And then while that's happening, the scanner also spins horizontally, so we capture the full scene of what's around us, 360 view, and then that captures 250,000 points a second. And then we'll move the scanner from the bow around one side, take a few scans, and then to the other side and complete the scan. From all the points, we can use that and then send the data downstream, and then use all that data to create a 3D model. Today, while we're at the shop, we've started with the hull mold, the insert mold, and the deck. And along with those three big ones, there are also hatch covers and inserts for recesses in the deck for all the control lines, spinnaker sheet shivs, and also looking at the rudder molds and really anything that we can do that might add value to have digitally captured in the future.
When I went through school for naval architecture, marine engineering, this kind of stuff was in its infancy. I'm used to doing it with my hands. You know, all the molds that we did were done with filling something, using a batten, using sanding blocks, and then measuring it again so that you knew it was done, it was right, it was within class specs before you went to the next step. You know, the net result is you want to have a boat that's class legal, that we can build, that will continue forward so that not just the Allen Boat Company, but hopefully another company or another iteration of the Allen Boat Company at some other time can continue to build the Lightning, and so it lasts for a long time.
Great. Now, could all of you see the video? Because I got one person that said they couldn't. Okay. All right, great. Shoot.
Yeah, so for me, at least, the video was a little choppy. We will send out a link to the video afterwards so that you can see it without the choppiness. I don't know if that's me. We're in the middle of a snow and ice storm here. Maybe that's slowed down my internet. Not sure. Bertie, did you want to share your screen again?
Yes.
Just so you know, the video came out fine for me. So I think it's just
Good.
your snow and ice.
Good.
Okay. There we go.
So let's walk through a very high level outline of the process. So the first, in addition to sort of gathering the people and making a plan, the first major step was the scan of the existing molds, and that happened in December at the Allen Boat Company. Andrew, do you want to talk a little bit more about that process and about what you need to do after the scans?
So Patrick and I came out to Buffalo, and we scanned the hull mold, the deck mold, a bunch of the inserts that go inside the boat. There was sort of a bow insert, and mid-body kind of insert that goes to the back, and a couple of other little bits and pieces. So we basically made a symmetric version of all of those. And because at the moment the parts were not fitting together that well. So I'm going to try and share my screen here if I can. So can everybody see my screen?
No.
Not yet.
It worked before, and I stopped sharing. There you go.
Here it comes.
It's starting.
So
Okay.
we have a sort of a series of surfaces. So we turn the scan data, which was this. This was kind of like the scan data that we got of the hull, And then we turn that into surfaces. So we made them symmetric surfaces. So there's a bit of a bump on this side, and there's a bit of a hollow here, and another bump. And if we go to the other side, we can kind of see as there's a bit of a bump where the other hollow is. So this is a reasonably fair piece from what you've got. Again, this transom is physically square across the boat. Looks like it's deformed a little bit over the years. And then I'll turn the mesh off. So from there, we place the deck on it. There's a little insert here for the jib track that could probably be built in somehow. That would save Tom having to make this extra part and then sort of attach it. Again, there's a centerboard trunk, the seatings, the locker spaces, and this is like a panel. So getting rid of the hull on the deck, this is sort of like the inner panel. So that's what we have so far. So from this point, a naval architect would need to make sure all of the gaps are correct between these sort of side pieces and the actual hull itself. This piece here and the hull, and also where this kind of sits on the hull back here, that's all correct. What we've done at the moment is we've taken the deck in yellow and we've done a small offset so that obviously the deck would have some thickness, and then this would be the outside of the hull that fits up in a shoebox type joint. So this would also have some thickness. And I think we've left like 3 mil or 4 mil in there. But then again, a naval architect should go in and sort of check that stuff. Again, this is a pretty constant all the way around. So this at the moment was our best way to actually get the side panels of the boat. This piece in here. So we actually knew where the chine was, but this was a bit loose. So we've just pulled that out to the deck edge. So this is all ready to go to a naval architect.
Right. Thank you, Andrew. And so the next major step in the process is for the naval architect to produce fair and finished tooling service 3D models. Obviously, we've got a great amount of work already done to start from for each of the mold parts. You know, the inside and outside of the hull, the top deck, the rudder, various other parts, and also create a 3D representation of the specifications so that those can be compared and we can know way before we ever start building boats, we'll know that the boats we're going to build are going to be within the class specifications.
Yeah.
And I know there's a question in the chat around whether the goal was to, I'll paraphrase it, whether the goal was to reproduce the exact tooling that we've already got, whether the goal was to produce a better boat. The real goal here is, number one, to make sure that we're building a boat within the class specs. Class specs have a lot of fairly loose tolerances. Some of you may remember from 40 or so years ago when we had some issues with builders that were trying to take advantage of those tolerances. So we're not trying to build a super boat. In fact, if the boat we build is a super boat, we will have failed. We need to build a boat that allows the 15,000 other boats that have already been built to remain competitive. But as Andrew alluded to the extent that we can do things in the building and the mold that will make the process easier for the builder in the future, like maybe including the jib track area in the mold instead of it being an extra part, for example, then that kind of stuff is fair game.
And
Patrick, did you
Tom,
want to add anything in about what the naval architect is going to be doing?
No, I think Andrew covered it pretty well. It's a lot of it is just kind of figuring out what changes we need to make, and then also what sort of improvements we can make in terms of making the boats easy to build. Everything's about money. So Tom has uh, an accurate idea of how long it takes to build the Lightning, what parts it takes to build the Lightning, and if we can make his cost to build it lower, and maybe that translates into making boats cheaper. Probably not, but just ease of building, and like Andrew was saying with the jib track kind of thing, like any changes we can make to just simplify the process and maintain class one design status and measuring in and not creating super boats so that all 15,000 of them are equal, then that's kind of the next thing. And a couple issues like Andrew was saying with the hull deck joint, just kind of making sure that's all correct, and really just going through the numbers and making sure that we're happy with the design, and then kind of how we move forward from there. And if there needs to be any changes to make along the way, then all that's fairly easy between Andrew, Tom, and PJ and I, and we can kind of figure all that out just to make sure the boat fits. Really is the big thing, but make it easier to build also is very important. So yeah.
Yep. Thank you. So then the next big step in the process is to create plugs. And has Tom managed to join the Zoom yet? Tom, do you want to
Yes.
talk a little bit about creating the plugs and what their role is?
Well, when you decide to build a set of molds, you usually make what we would call a male mold. For fairing purposes and shaping, you can fix anything on the outside shape like what a boat would be. You can fair the outside, change it, and then shine it up, and then take an impression, which is the mold from that to build the boat. If you tried to build a female mold, which is what we use to build the boats, it's really hard to finish the shape because you're inside the mold and trying to fair it in and make it look good. Anyway, basically you have to make some kind of a tooling to then make the mold. That's the basic idea of what a plug is.
Thanks, Tom. And then the molds themselves. What can you tell us about that next step?
So, a lot of this, as I said in the video, is a little new to me because I'm used to doing it myself. But my understanding is they make a set of plugs, or there's lots of different ways to do it, and then they put a bunch of medium on it. Looks like some kind of a tooling putty almost, if you will. And then when that goes hard, they take a 5-axis router and they cut the shape out of it. It gets pretty close, but there'll still be some handwork to be done afterwards. If you envision the router making a pass with a round head, you can't make it exactly the same, but you can get it very close, and there'll be some hand sanding and then finishing to get the shine where you need it. Like anything that you're building, that you're making a representation, the boat that comes out of the mold is only as good as the mold and usually not quite as good. Well, the mold is only as good as the plug and usually not quite as good as the plug. So you really spend a lot of time on the plug to make the mold really good so the boat looks really good.
Super. Thanks, Tom. And has Dave Sprague managed to join the call?
No, he has not. He's down working that regatta in the islands and was going to try to.
Okay. So who wants to talk about the process after we build a boat of measuring it, certifying the molds, and any two-boat testing or whatever that we might do to make sure that we didn't build a dog and we didn't build a superboat?
Well, I guess that's probably me at this point if Dave's not on. I've done the measurements a number of times. Essentially, to certify the molds, you have to build a boat out of the molds, put it together, and then, relatively soon after that, you need to uh, measure the boat. The measuring process is, it's not simple, shall we say. There's a bunch of different ways to do it. You can use a string line or you can use a transit, but there is basically 10 stations on the boat, the transom and 9 others, and you take a slice of the boat across the boat, and at each slice you're measuring the center line height, the chine height, the shear width, and the chine width. And then there's a bunch of other measurements. When you're all done, you can say the boat is a legal lightning. If you get to that point, then you can then certify the molds. If for some reason the boat didn't fit, you could modify the boat and make the boat a lightning, but you couldn't certify the molds unless you were able to correct the molds and then build another boat that was correct and then that was measured. So as far as the testing goes, there's really not an easy way to do a two-boat testing. In the past, we've always just started using the boat. I would use it competitively or have my father or other people would use it. And it's sort of, it can be a long drawn out process, which is really what you want, because that would mean that it's such a small difference that you can't tell. And when we start talking about, everybody says, oh, I'm really worried. The differences that we're talking about are extremely small. And you say, well, how small? Somebody says, oh, I only want to be 1% faster or I don't want to be 1% slower. And I tell people 1% is astronomical. If you had 1,000 boat lengths in the weather leg, you'd be 10 boat lengths ahead of everybody if you were 1% faster. So, when we start talking about that, it's really hard to tell whether you got a fast boat or a slow boat if we're talking about small differences and changes. We're not trying to go way outside the extremes. We're trying to make something that will stay legal for a while, stuff that will uh, keep the same speed. We're looking to try and keep the same speed, the same quality, but we are trying to see if we can't either make some stuff easier to build or make it easier to use. And to that degree, we've already started talking to the class, is there anything else that we can change, that would entail changing the specs? Because if you're going to do something like that, you would do it now. But, my intent, and I would hope anybody in the class's intent would be to not change anything that had anything to do with the speed of the boat. That if you're going to make a change, you want to make it something that is safer, more fun to use, easier to use, but not necessarily change the speed. So that's sort of my 2 cents on the boat and the mold and the measuring.
Thank you,
So
Tom.
then, yeah, do we want to spend just a minute on the timeline, which, whoops, is certainly subject to change?
Yep. So, as we said, the scanning was done in December at Allen Boat Company. Naval Architect will start engaging very soon now. and that'll go on for a little while. The tooling for the plugs, this will all be digitized so that it's repeatable. Things being built from numerically controlled machine tools. Tooling for the plugs in the middle of the year, tooling for the molds towards the end of the year. And my personal goal is that at the Helly Hansen St. Petersburg next year, we're looking at a new boat out of the molds racing with us.
And I must say that when I reviewed this with Tom, he did feel this was pretty aggressive. So again, obviously estimated timeline subject to change, but we'll challenge PJ as the head of the team to keep us on track.
All right, well, I'm going to chime in for 1 second then if I'm getting called out. So first thing is that, working with everyone has been great. I was on that first trip, sort of the pre-trip to Buffalo with Tom and met with his team. And it was great. I learned a lot, and Tom is very good boat builder. He's a great boat builder, and he's also a naval architect. So he understands exactly the nuts and bolts of what we're dealing with here. I work like Andrew and Patrick in the manufacturing of these 3D, CNC machines. I'm right there. That's a daily occurrence in my life. So I get it. And what's really going to need to happen at this point is, we need to get Tom and the naval architects, plural, or architect, and Andrew all together, and we're going to get this shape figured out. And then there's some decisions to be made on the, what style plugs we need to make, maybe not permanent plug, like something that we can do one tool off of just to see if we're okay. And there's some options here. So we're going to have to really work through the options and the timeline, but it looks fairly doable to me on the scale that you guys have. It will be aggressive for sure. The biggest thing is we're going to have to get somebody to cut these tools. I have a lot of connections, and I know Patrick and Andrew do as well in this world. So we should go and get quotes and see people's deliverables and timeline, and then we can make an assessment as a class where we want to go. Does that sound good?
That's great. Thank you, PJ. At this point, let's open it up to the participants, to the audience to ask questions. And we'll see if we can stump the panel. Let's try and keep the questions sort of relevant to the topic. I know there's some questions in the chat, for example, about experiments that we may have done in the past around asymmetric spinnakers or larger jibs or whatever. Let's try and keep it to the current topic if we can.
Bob, can you hear me okay or no?
Yes, Dave.
Yeah. Hi. I just I didn't have a chance in the beginning because I was having issues, but I just wanted to say thank you to everyone who's on the call from my position in the class. None of this is possible without the donation support of everyone. And I just wanted to make sure I just took 10 seconds to thank everyone who is on this call and those who aren't for their support of the Lightning class. As you can see, there's a lot of work going on. Is Bill Cabral on the call? He may not be.
No, he's not.
But okay.
I don't think so.
Well, to echo what Bill said, we were on a call last week, and what Bill Cabral said on the call to many of us is, good things like this take time, and we all want it to happen aggressively and fast, but you have to be careful when you make changes to he used the example of when we simply change where the insignia, the country code, and the numbers go on a sail. You would think that would take about 5 minutes, but it took a long time, and you have to be careful. So my point of saying this is it's important for everyone to kind of be respectful that this process takes time, and but in the end, you want to do it right. So anyhow, thank you very much, everyone, for joining tonight. Appreciate it.
So one of the questions that we've heard is, what's going to happen to the first boat out of the new molds if it's not certified? Can it be reworked to be compliant? But then we'll have to go back and rework the molds afterwards and try another boat. Will it get thrown away, cut in half, sell each side as a bar or a flower garden? Um, Not sure who wants to take on that question of what happens if the first boat out doesn't
Well,
certify.
I'll jump in again. I sort of answered that to some degree, but I'll add a caveat. It depends on how far out you're talking about. I mean, if you're off by 10 degrees or something, then you got a problem. If you're, you know, an eighth of an inch someplace, we can rework the thing and make it a lightning. But, it just depends on where you're out and how hard it is to change. But boy, I would hate to throw away X thousands of dollars in a boat if you could fix it and make it a legal lightning.
I would certainly agree with that. Um, Another question that we've heard, what's the total cost of the new molds, including the entire process, and how are we doing raising the funds that we need to pay for that? Um, and I'll take a partial whack at that and see if anybody else from the team wants to chime in. Um, as some of the panelists have already said, some of the things we know a lot about. We have preliminary rule of thumb quotes for. There are other things that we know in greater or lesser detail. And so the estimated cost for all of this is a couple of $100,000. As you know, we've been very successful in our fundraising in the first year of the fundraiser. And so I think we're in good shape in terms of funding the overall campaign and the new molds. But as the next year plays out, we may find that I mean, it never happens that it costs less than you think, but I suppose it could. But we could also find that it costs more, and your continued generosity, I'm sure, will help us take care of it if that does happen.
One of the questions, and maybe Tom covered this, or Bob, maybe you did. If we decided that we wanted a second set of molds, what would that process be? Is that easier to do? Maybe much easier to do now that we've done the scanning. And maybe that's what you just addressed, and I apologize
Well,
if it is.
certainly there's a lot of stuff, if you have a digital file and you're willing to pay to have the molds made, you don't have to make the plug again yourself. And that's the long term. You've also saved it in price, so that you can do it again some other time and not have to when we originally made the molds, we had to take a boat and take it apart and build a plug and then build a mold from it. And we've done that several times since then. It is probably a lot easier to start from a drawing if you can get a mechanical way to reproduce it. I don't know. Again, I have not done it this way before, so I'm sort of learning from all these guys also at the same time. But my my guess is that you'll get an accurate representation much faster and be able to build another set of molds or plugs, as the case may be, relatively quickly. Maybe PJ can step in on that one too.
Yeah, I was just going to say, Tom, that's really good. I think when Dave first approached me about this in North Carolina during the North Americans, he knows that I work in this world a little bit, so he asked me a little bit just to describe done, which is to digitally capture all the work that Tom and the Allen Boat Company have done. And really the best thing about that is that data is the classes now. You have it, it's there. We can manipulate it to however we want. The one thing about computer aided design or CAD work is that it makes the editing process much quicker than doing it by hand, as Tom said. So I think really the big thing was getting the data in, and now how we use the data, I think to Dave's point, is really that's where we have to think a little bit as the class. And multiple tools. Yeah, we can do a lot of stuff. We can make plugs that we can do 3 or 4 sets of tools, or we could do plugs that do 1 set of tools, but then the tooling materials cost more. So there's a balance here, and it's a little bit of a strategy on figuring out. The other thing I would say is I'm fairly confident, having again worked in this world, where the output that we're going to get from a CNC machine, I wouldn't worry about the first boat being 10 degrees off, or more than a 1/4 inch off in places. It's very unlikely unless there's an error with the machining or something, but there'll be quality checks and other steps in the process that are going to allow us to monitor it as we go along. I don't know if that explains kind of where we're at, but I think really the best thing is we've captured this information, and now we let all these artists and the clever engineers and the naval architects really go to work on making a nice long-term set of tooling for the class.
Thanks, PJ. Are there any questions from the people attending the Zoom?
We're right about at 45 minutes, and we wanted to keep this kind of in that time range, 45 to 60. So I think maybe if there are no questions, it'd be a good time to wrap.
Yep. So thank you so much to our panelists and the people on the molds team that are putting a lot of their efforts into this. Thank you to all the people who attended for your interest. And again, thank you so much for your generosity. If you have any feedback on how this went, we'd love to hear it. Is this the kind of thing that you'd like us to do as we make more progress on the molds and as we make progress on some of the other streams that we're working on as a result of Fuel the Flash? Love to hear your feedback and your thoughts about the future for this.
Hey, Bob, this is Pete Denton. Can you hear me?
Yes.
Yeah.
Oh, okay. I was finally able to get on the call on my phone, not my computer. Okay, I just wanted to make sure I communicated. A lot of old friends on a call. Hi, everybody.
Pete has been truly instrumental in helping guide us to the 5-year strategic plan. So we really owe him a special thank you. Yeah.
Yeah. And I won't take the time to do full introductions because we're going to have an email that comes out in the next few weeks. But Peter is one of the members of our Fuel the Flash advisory board. And Pete Denton, Sandra Moore, Lauren Psyche, and Mike Hoffman are the 4 members of the advisory board, and they've been instrumental in helping guide us through the fundraising that we're doing so far and through the efforts that we're making as a result of the fundraising. So a huge thank you to all 4 of them as well.
Right. Okay. Anything else from anybody? And
well, I was just gonna say, it's Dave. I was just gonna say real quick, thank you to Bertie and Bob Shapiro for really doing all this hard work. I really appreciate it. So thanks to you too.
Yeah, here.
Thank you very much. Thank you. And as Bob said, we'd really love to hear your feedback. So on an ongoing basis, if this is something that that's helpful to you, we are going to make this link available to everybody, to all the members of the class. But again, this was a special thank you to the donors. So thank you very much. And if you'd like to please tell your friends to check out the link and watch the video. I think
Thanks, everybody,
with that,
and good night.
Yeah. Thank you so much. Have a great evening.